Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty, so we're going to start with Chapter 5 or Objective 5 or whatever you want to call it, to do with 5. And we're going to be dealing with exponents. Let's start out with a statement like this. If I had 4 squared minus 3 squared, wouldn't that be 16 minus 9, which is 7?
Yeah.
Okay. So this is 4 squared minus 3 squared. What's that? Is that minus 3 squared? Would that be minus 9, just like it is here? Yes, it would be. This situation, the base is just the 3. So this is 3 times 3 with a negative sign in front of it. Now, that differs from the following expression. Here, the base is all of the negative and the 3. So this would be negative 3 times negative 3, which is positive 9. So this is not equal to that. If we want the negative sign to be included as part of the base, it has to be inside the parentheses to which it's raised to a power. Okay, another example. Negative 2 to the 4th power versus negative 2 to the 4th power. The first one is 2 times 2 times 2 times 2 with a negative sign in front of it. The second one is negative 2 times negative 2 times negative 2 times negative 2. Negative times negative times negative times negative is positive. So we get a positive 16. So these are not equal expressions. Any questions about that? Any more clarification needed? Now, suppose we've got this, however. These are different expressions. The first one is 2 times 2 times 2 with a negative sign in front. The second one is negative 2 times negative 2 times negative 2. You get the same answer, but the process of getting there correctly is different. Here, the base is 2. Here, the base is negative 2. But because it's an odd exponent, you end up with the same answer. But these initial expressions are not the same. They mean different things. All right. Let's get to the rules involving exponents, or the properties. Let's say we've got x squared times x cubed. If we expanded both of these factors, we'd have x times x for the first one, and then times x times x times x for the second one, which means we have x times x times x times x times x, which would be x to the 5th power. So x squared times x cubed equals x to the 5th power. Well, I could go through a whole bunch of examples of this, and sooner or later, you would conclude that in general, if we have, let's say, a base raised to a power times the same base raised to a power, the rule is we take that base raised to the sum of the exponents. So here's one of the rules. So for instance, y to the 4th times y to the 7th would be y to the 11th. W cubed times w cubed would be w to the 6th power. X squared times y cubed would be x squared times y cubed. Why didn't I combine anything there? Because the bases weren't the same. For this to work, you're multiplying 2 powers with the same base. and then you add the exponents. Any questions about that rule? All right, let's take a look at another rule. Let's say you've got a power raised to a power. If we expanded this, that would be x squared times x squared times x squared, because we've got 3 factors of the base x squared. But then using that first rule, multiplying powers with the same base, add the exponents, you'd get that, which would be that. So how do we get from here to here? We multiply the exponents. So a power raised to a power, you multiply the exponents and attach the product to the same base. So for instance, w cubed to the 4th power would be w to the 12th power. Y to the 2nd to the 6th power would also be y to the 12th power. Now, let's take a look at these 2 rules. Maybe we should put them side by side. They're similar, but extremely different. For instance, x squared times x cubed would be x to the 5th, but x squared, the quantity cubed, would be x to the 6th. So be careful not to get those rules mixed up. Any question about either of these rules before we go on? All right. Next rule. Let's say we have a product raised to a power. We take the power outside and attach it to each factor inside. So for instance, x, y, the quantity cubed, is x cubed, y cubed. 2w to the 4th power is 2 to the 4th power, w to the 4th power. This one we can take further. 2 to the 4th power is 16. So we get 16w to the 4th power. So again, if we have a product raised to a power, we take the power and attach it to each factor inside the product, or of the product, I should say. All right. Any questions about that? Okay. Let's see. Next rule. Let's say we've got x to the 4th divided by x squared. If we were to expand this and do it the long way, we would have 4 factors of x in the numerator over 2 factors of x in the denominator. If we were to go through and reduce x over x to 1 over 1, x over x to 1 over 1, we end up with x squared. If we had x to the 6th over x to the 3rd, we'd have x times x times x times x times x times x over x times x times x. You can see that you really don't want to do it this way. That reduces down, that reduces down, that reduces down, and I'm left with x cubed. So how do we get from there to there or there to there? We subtract the bottom exponent from the top exponent and attach the result to the common base. So a to the m over a to the n equals a to the n, m minus n. Let's look at some more examples of that. So x to the 7th over x squared would be x to the 5th. Y to the 13th over y to the 2nd would be y to the 11th. W to the 45th over w to the 40th would be w to the 5th. All right. Let's take a look at this one. Let's say I have a quotient raised to a power. When you have a quotient raised to a power, you attach the outside power to both the numerator and the denominator of the quotient. Let's say, for instance, I have 2 over x to the 4th power. This is 2 to the 4th power over x to the 4th power. This one I can go further because 2 to the 4th is 16. So I get 16 over x to the 4th power. So in general, we have, let's see here, we'll write a over b to the n equals a to the n over b to the n. Okay, let's see here. Suppose I just have x. What is the implied exponent on that? Well, x is equal to 1 times x to the 1 power all over 1. So there's all those 1s there if we need them for whatever reason. But basically, x to the 1 power is the same as x. So when the exponent is a 1, generally we don't bother to write it there. We just leave it as plain old x. All right. Now, let's go back and let's look at, let's see here. This rule again, where we're dividing 2 powers with the same base, and we subtract the bottom exponent from the top exponent, okay? Let's see, I've got the following situation, x to the 5th divided by x to the 5th. Well, using that rule that we just looked at, this would be x to the 5 minus 5 power, which would be x to the 0 power. All right, let's do this problem a different way. Assuming that x is not 0, because otherwise we'd be dividing by 0, isn't the quantity in the numerator equal to the quantity in the denominator? So wouldn't this reduce down to just 1? Let's look at it a third way. X to the 5th over x to the 5th is x times x times x times x times x over x times x times x times x times x. We could reduce that down to 1 over 1, 1 over 1, 1 over 1, 1 over 1, which is just 1. So this equals that, but it also equals that, which leads us to the following conclusion. A base raised to the 0 power equals the number 1. Now, this is going to bother some of you. You'll lose some sleep over it. You'll get used to it. Courtney's going, yeah, I'm already getting a headache from it. Anyway, so we've got to be careful that we don't confuse that rule with this rule. So if you've got a base with no exponent, the implied exponent is a 1, not a 0. If the exponent is a 0, you need to put the exponent there, but a base, anything other than 0 to the 0 power, any other number to the 0 power equals the number 1. So 43 to the 0 power equals 1, okay? 4x, let's see here, hang on. 4x squared y cubed z to the 0 power equals 1. Okay, anything to the 0 power other than 0 to the 0 power, we'll save that for calculus. Okay, got to save something for calculus. Let's see. All right, now let's go back to this idea. So dividing 2 powers with the same base, subtract the bottom exponent from the top. Don't forget there's an implied 1 there. So 3 minus 1 is 2. So x cubed over x is x squared. X to the 5th over x squared would be x cubed. X to the 7th over x to the 7th would be x to the 0 power, which is 1. But wait a minute. What if the exponent on the bottom is larger than the exponent on top? Well, then we get x to the 3 minus 5, which is x to the negative 2 power. So now we've got an exponent that's negative. Well, let's do this problem a different way. Let's do it the long way again. So I've got 3 factors of x on top over 5 factors of x on the bottom, reducing it down. I end up with 1 over x squared. Well, if this equals that, but it also equals that, then it stands to reason that that equals that. So what we get from that is this. A base raised to a negative power, so like x to the negative 3 power, is equal to 1 over that base raised to the positive power. So you change the sign of the exponent. In general, we'd say x to the negative n equals 1 over x to the n. So x to the negative 4 is 1 over x to the positive 4. Y to the negative 3 is 1 over y to the positive 3. What about this? What about 1 over y to the negative 2? Well, we can move it upstairs, and it changes the sign of the exponent as well. So moving it across the fraction bar, if it's negative on the top, you move it down below, it's positive. If it's negative on the bottom, you move it up, and it's positive upstairs. Okay. What if I have this? X to the negative 2 over y to the negative 3. Couldn't I switch them both and make them both positive? So that gets us this idea. Again, you're taking the reciprocal of the base, and it changes the sign of the exponent. Remember what a reciprocal is, or a refliprical, as I like to call it. Okay. Okay, let's see here. Let's say you've got this, x over y. Oh, I guess I did that right here, forget that. Well, to the negative 3, that would be y over, that would be y over x to the positive 3 power, right? Take the reciprocal of the base, it changes the sign of the exponent. All right, so there's all the rules. Let's look at some more examples. What about 7 to the 0 power? What would that be equal to? Anybody?
1.
Excellent. What about 3/8 to the 0 power? What would that be equal to?
1.
Excellent. Be careful. What about 8 times t to the 0 power? What would that be equal to?
1t.
8.
Yes, it would be 8. Why is that? The 0 exponent is only attached to the t. So this would be 8 times 1, or just 8. Let's contrast that with this problem. Oops. Here, the 0 is attached to the entire 8t. So this whole thing would be 1. But this first example, it's as if though there were parentheses around the t. That 0 is only attached to the t. Here, it's attached to the whole thing. So you've got to be careful with how things are grouped. All right. How about this? 4 divided by 3a to the 0 power. What would the numerator be?
4.
Careful. What would the denominator be?
3.
Right, that's just like that previous example. So basically the 0 is only attached to the a, so this is 3 times 1, or 3. Excellent. Okay. What about this? 2 to the negative 2 power. What would that ultimately be? Oh, and by the way, typically when you're writing a final answer, unless it tells you otherwise, you want to write it with positive exponents only. The only exception to that is scientific notation. Okay, but anyway, so here we would have 1 over 2 to the positive 2 power, which is 1 over 4. Now, a common mistake that students make is they'll write this because they think that negative sign makes for a negative sign on the answer. No, this is a negative exponent. That just makes for the reciprocal situation. Okay, it doesn't make the answer a negative number. Okay, how about this? 5 to the negative 1 power. So that would be 1 over 5 to the positive 1 power, which you would just write as 1 over 5. How about this? Negative 8 to the negative 1 power. So that would be 1 over negative 8 to the positive 1 power, which is 1 over negative 8, which is negative 1/8. Why did I move the negative sign upstairs? Because we typically don't leave a fraction with a negative sign in the denominator. We either put it in the numerator or out in front of the whole thing. Okay, that should be reviewed, that little ditty there. What about this? Negative 9 to the negative 1 plus 9 to the negative 2. So that would be what? Negative 1 over 9, because again, the base for this is just the 9. And then plus 1 over 9 squared. So negative 1/9 plus 1 over 81. But the common denominator there would be 81. So we'd multiply the first one by 9 over 9 to get negative 9 over 81, plus 1 over 81 is negative 8 over 81. Okay with this? A lot going on there, I know. How about this one? 7 to the negative 1 power plus, oh wait, minus, my bad. Minus 7 to the 0 power. Well, this would be 1 over 7 to the 1 power, or 1 over 7, minus 1, which is 1/7 minus 7/7, which is negative 6/7. Doing okay? Again, if I'm going too fast on something, let me know. Is your brain about to explode? Maybe, maybe not. Okay.
Yes.
Yes? Okay. How about this? 16t to the negative 3 power. What's the base for the negative 3? It's just the t. So this is 16 times 1 over t cubed, or 16 over t cubed. So the negative 3 is not applied to the 16. For it to be applied to the 16, it would have to be written like this. Okay. How about this? Negative 6 to the negative 3 power. Again, here the base is just the 6. So this is like negative 1 over 6 cubed, which is negative 1 over, I think 6 cubed is 216. Let's see here. 6 times 6 times 6. Yeah, 216. All right with this? What about this example? 6 over k to the negative 2 power. Well, that would be 6 times k to the positive 2 power, because that would move upstairs, making the exponent positive.
So it's not division anymore. It turns to just a fraction. How are you going to know if you're actually supposed to divide it or leave it like that?
Because of the negative exponent. You want to get rid of that negative exponent. And when you do so, it's no longer a division problem. It's a multiplication problem. So you get rid of that, which means you'd have to write it this way. Is that making sense?
Not really.
Not really. Okay. Now let's look at some more of those then. Let's see here. So this is a division problem, but I can rewrite this as y to the second power in the numerator, which then I don't really need to write the over 1 because it's implied. What if I just had this? That would become that. Does that make sense?
Yeah.
So let's see here. So let's get rid of that. So this thing here is just like that. So this piece is the same as this, okay? Just kind of separating them out. So this piece here is going to end up like that, and this piece is going to stay as it was. So you're just moving this piece to make the exponent positive. What about this? This would become that, because that moves downstairs and becomes positive. That moves upstairs and becomes positive. That is, the exponents become positive. Cross the line, change the sign of the exponent. How are we doing, Whitney? Is it getting any better?
Yeah, that one makes.
That one makes sense. All right, what about this one? 8 divided by s to the negative 1 power. So that would be 8 times s to the positive 1 power, or just 8s, because you're taking this piece and moving it upstairs. What if I had this, x to the negative 3 y squared over z to the negative 4th w cubed? So I don't have any bases that are the same. They're all different. But I want to rewrite it with positive exponents only. So this has got to be moved, and this has got to be moved. So x to the negative 3 on top becomes x to the positive 3 on the bottom. Y squared on top stays. Z to the negative 4 on the bottom becomes z to the positive 4 on top, and w cubed on the bottom stays. So what am I doing? I'm taking the factors with negative exponents and moving them across the line so that now everything has positive exponents. We doing okay with that? I'll take that as a yes, I guess. All right. What about this one? 2 over t to the negative 4 power. So that becomes t over 2 to the positive 4 power, but a quotient raised to a power. We attach the power to both the numerator and the denominator. So this, we take the reciprocal of the base and it changes the sign of the exponent. Then we've got a quotient raised to a power. So we attach the power to the numerator and the denominator, and then 2 to the 4th power we can multiply out. So we do. You okay with that example?
Yeah.
All righty. To say if you're not, let me know. Let's see here. Okay, m to the 10th times m to the negative 6 power. This goes back to the first rule we looked at, which said multiplying two powers with the same base, you add the exponent. What's 10 plus -6? It's 4. Let's do this same problem a different way. Instead of treating it as multiplying two powers with the same base, we'll add the exponents. Let's take this expression and let's rewrite it, making the second factor so that it has a positive exponent, which we would do by moving it downstairs, right? But now, dividing two powers with the same base, what do? You subtract the bottom exponent from the top. So we get to the same answer a couple of different ways. So there's all these different rules that you just have to be sure that you're using them correctly, but there may be more than one way to get there, as this example shows. Okay. Any questions or comments about this? Okay. How about this one? T to the 7th power over t to the 10th power. So that would be t to the 7 minus 10 power, which is t to the -3 power, which is 1 over t to the +3 power. Now, doing the problem this way is just using the rules that I gave you. But if you can see that from here, you can go to here, because you've got 7 factors on top and 10 factors on the bottom, then you can skip those 2 steps. But don't do it unless you're really confident in it, okay? Some authors actually have a rule that's the shortcut of that, but I'm just going to stick with this officially, because that uses rules that we've given. Okay. Okay, how about this one? Where did it go? Let's see. Y to the -3 power squared. Well, a power raised to a power, you multiply the exponents. Now, what you're not seeing is the directions are saying, write your answer without negative exponents. That again, whether it says that or not, that's always implied. But then this would become 1 over y to the 6th power. That's how we get there. Another way we could do this problem is we could rewrite it like this. Okay, taking this and putting it 1 over y cubed, and then we'd have that as well. So again, there's another way to get there using the rules. Okay, what about this scenario? X squared times x cubed. What would that be? X to the,
5th.
all right, x squared cubed. What would that be?
X to the 6th.
Excellent. X squared plus x cubed. What would that be? Careful. I'm trying to trick you. Do not be fooled. That would be x squared plus x cubed, because we're adding and they're not like terms, so we can't do anything. So you got to be careful of the operation. What about x squared plus x squared? What would that be? Bless you. That would be 2x squared, because those are like terms, so we'd add their coefficients. Oh yeah, so we're taking the new rules and then looking at the old rules. Got to keep those straight. Just when you thought it was safe, your brain exploded. Have any of you seen the movie Mars Attack? It's kind of a dumb movie, but the Martians, their brains explode and green slime goes everywhere. Sometimes I feel like that's what happens to our brain. We put too much math in it and just kind of, yeah. All right, what about this? X to the negative 12th power over x to the negative 3 times x to the negative 4. Ultimately, you want positive exponents, but that doesn't mean you have to fix them immediately. This is kind of up to you. So I could do this. I could fix all the negative exponents and make them positive and do that first. Could do that. And then this would be what? X to the 7th over x to the 12th, which would be x to the 7 minus 12, which would be x to the negative 5, which would be 1 over x to the 5th. So here I put that there and that there. And then I combined those. And then I divided. And then I turned it into a positive exponent. Okay. We all right with that? Any questions there?
Can you do another one like this?
You betcha. That's supposed to be a B. B to the negative 2, B to the negative 3, B to the negative 9. So this could be written as B to the positive 9 over B squared B cubed. So moving everything to the other side to make the exponents positive. Then I could multiply those two powers with the same base. So I'd add the exponents. And then I'm dividing two powers, so I'd subtract the exponents. We get that. You follow that okay, Nellie?
Yeah, thank you.
However, we could also do this problem this way. I could leave the stuff up top and just take this and move it upstairs, which would make it positive. But now I'm multiplying powers with the same base, so add the exponents. What's negative 2 plus negative 3? That would be negative 5 plus 9 would be positive 4. So I could do that. Again, whichever way you feel most comfortable with. So you've got some options, but you've got to make sure that you're not breaking the rules when you use your options. Okay, how about this one? 6 to the negative 2 power, B to the 9th, C cubed, over 5 to the negative 3 power, B to the 4th, C to the 8th. All right. I'm going to look at this thing in pieces. Let's take this first piece. I could rewrite that as 5 to the 3rd over 6 squared, like that. Which would then be 125 over 36. 5 cubed, 5 times 5 times 5, 125, 6 squared. Then I can look at this piece. B to the 9th divided by B to the 4th is B to the 9 minus 4, or B to the 5th, but that's up on top. Okay with that? C cubed over C to the 8th is C to the 3 minus 8. Is C to the negative 5 is 1 over C to the 5th. So that C to the 5th would be in the denominator. Just kind of to show you where everything ended up. I'm just having too much fun using all these different colors. You okay with that? I
Can you
know.
do another one?
What's that?
Can you do one more?
Sure, you betcha. Let's see here. Okay. 2 to the negative 1, a to the 4th b squared over 3 to the negative 2, a squared b to the 4th. Okay, so again, let's look at each separate piece. That's going to be 3 to the positive 2 power over 2 to the positive 1 power, which is going to be 9 over 2. So it becomes this, it becomes that. All right, with that part,
Yes.
then let's take this. A to the 4th over a squared is a to the 4 minus 2, or just a squared, and that's up on top. And then finally this, b squared over b to the 4th is b to the 2 minus 4, top exponent minus bottom exponent, which is b to the negative 2, which is 1 over b squared. So we've got the b squared in the denominator. So we get 9a squared over 2b squared.
Thank you.
You're welcome. How we doing? We still got some time. How about this one? Xy cubed over x to the negative 1, y to the negative 1, all cubed. Order of operations, you'd start inside the parentheses. So I'm going to look at this. X over x to the negative 1 would be x times x to the positive 1, which would be x squared. So basically this got moved upstairs, which gave it a positive exponent. Don't forget there's an implied 1 there as an exponent. So x divided by x to the negative 1 becomes x squared. And that x squared is in the numerator. Okay. Then let's take a look at this. We've got, oops, let's see, y cubed over y to the negative 1, which is y cubed times y to the positive 1, which is y to the 4th. So that's that. But we still got a cubed outside, don't we? This thing. So now I've got x squared y to the 4th all to the 3rd power. So I've simplified inside down to that. Now I've got a power raised to a power times a power raised to a power, because I attach that outside power to each factor inside. So I get x to the 6th, y to the 12th. How about this one? Anybody? Yep, it's 1. Now you could simplify what's inside first and you'd get z over x because the y's would reduce. And you'd have an x on the bottom and a z on top. And then you could do this. And then you could do this, but it's just all raised to the 0 power. So it's just 1. How about this one? 3w to the negative 8 x cubed all to the 4th power. So we have a product raised to a power. So that's 3 to the 4th times w to the negative, oops, wrong one there, sorry, to the negative 8th, but that's also to the 4th, and then x cubed, but also to the 4th. So we have a product raised to a power. So we attach that power to each factor inside. But now we come back 3 to the 4th, 3 times 3 times 3 times 3 is 81. A power raised to a power, we multiply the exponents. So that's w to the negative 32 power, and then x to the 12th power. Again, multiplying the exponents. But now we've got to rewrite it, 81 x to the 12th over w to the positive 32 power to make that negative exponent positive. So many rules, so little time. What's a person to do? Just watch the Mariners lose. That way you can be depressed either way. All right, now, this is a problem that I often give in class. I've given this to my pre-calculus class, and about 2/3 of them miss it. Let's see if you can get it correct. No pressure. -2x to the -2 power. Here are the instructions. Rewrite this expression using only positive exponents. I should have the Jeopardy music going. Doo, 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 doo. Let's not.
Would you make it a fraction over 1 and then leave it as a -2x and then positive 2 as the exponent?
So describe that again. It would you'd have
1 over -2x positive 2.
nope. Why are you moving that? That's not an exponent. Yeah. Here's the trick, okay? Rewrite this expression using positive exponents only. This is the exponent. That is not an exponent. You can't take -2 and what typically they don't do this, they do this. They say, oh, I'll just move it downstairs and make it positive. If that were true, we could balance the budget for the country just like that. We're in the whole $80 gazillion. Well, we'll just make it 1 over positive $80 gazillion or whatever. Okay. So there's nothing you can do to that. You can only fix the exponent by moving it across the line. All right. Okay. It's time. I got to go. Have a wonderful day. And I will see you all tomorrow. I'll be back at 1:15 with an office hour should you have need of me. All righty. I'm going to stop the recording.